Hi guys, welcome to see our weekly discussion. In the second lecture, we are going to introduce the linear model. Thanks for Sunking for providing very nice resources. This is our contractor. Last time, we briefly talked about the machine learning, how it works. We are using label training datasets for training the model. Once the model is trained, Once the model is trained, we use our dataset called the test dataset. We evaluate our model. This is the basic consideration in machine learning. Particularly, we call this type of machine learning as supervised learning because we use provide the datasets with answers. To train them, supervise the machine learning. And then the first task we want to do here is that we want to design our model. For the machine learning, it takes input hours as x and predicts points y. We need to find the best model for this. Let's look at the data. What is input? What is output? In your case, if you spend more time, you probably have higher points. If you spend less time, you can get lower points. So, two data hours and points, it's basically linear relationships. Not only this case, we can find many cases that are linear relationships. For example, if we want to predict house prices based on the size of the house, usually they have a linear relationships. Or if you want to predict the weight of a human, you can see the height and the weight. They usually have a linear relationships. So linear relationship is really important, pretty simple, but it's really good to start with. So in our case, we are using exactly that idea. In our slide, that by the way, it's a bit complicated. We will simplify our model with a very simple form: x times w. Time is the weight. Then if we have this kind of a linear model, we can draw this line. It is x for the given input. It is y. It's actually our true line. But unfortunately, our machine does not have any insight from that data. So usually we start with a random value w, and then from this random value we want to fit the line. This gets to the real data. This is the process of learning. For example, we have a random guess, and this is another random guess. So probably we have more cases like this. The goal is we want to find out the line to close the true line here. Then we need to measure which line is better, so we can move towards to close the true line. What is the best way to measure it? The basic idea is just keep the data point. And we just measure the distance between them. This is the simplest idea. This is y value, and this is y hat value. This. So basically, we find the differences between them. Since it doesn't matter, it's going to minus the difference and do square on this square. So we call this one as the error. The target of this machine learning is that we want to make this one really small. Formally, we are going to say that error, and sometimes we call the loss, which is defined by y hat minus y, which computes the differences and then to square. The y hat is something like this. So we can just express this form. The loss of some example are here. W, it's a random guess. So we want to see how this loss can change using different case over W. We can start W3. Then the y hat can be computed in this x times W. So it's 1 times 3 is 3. When x is 2, it's going to be 6. When x is 3, it's going to be 9. Once we have this way header, we can compute the loss, especially find out the differences and to square. For example, here, the difference is 1. 1 square is 1. And here, the difference is 2. 2 square is 4. And here, difference is 3. 3 square is 9. What we are going to do is average the summer. The sum of differences, the sum of the loss. Okay. Similarly, this is another case. The W is 4. We can compute the y hat values. Then we can find the differences to square. It's a little bigger than the previous, so the loss per dataset is the sum of this divided by 3, basically the mean over the loss. We can continue this process. Basically, what we want to do is, if we want to understand how this loss value is changing, based on this W. Similarly, when W is 0, we can compute this like this. We can see the differences and compute the loss. It's a very simple case. We continue this one. When W is 1, we can compute the y hat. We can call all the loss and the mean over the loss. And then when W is 2, this is interesting case because we predict something correctly, exactly. The loss is basically 0, which means our loss correctly indicates the error is 0 between the prediction and the real value. More formally, we are going to say the loss is sum over all the data point, which like then 2 divided by n, which is like average. We are going to call this as MSE, mean square error. They can be computed in this way. When W is 0, the MSE is something like this. When W is 1, MSE is 4.7. When W is 2, MSE is 0. When W is 3, MSE is something like this. When W is 4, MSE is 18.7. So when talk about the machine learning, we want to find out the value. They minimize the MSE automatically. If you want to understand the loss graph better, here is what we are going to do. For given W, given weights, we compute the loss. For example, when W is 0, the loss is 18.7, around here, 0. When W is 1, the loss MSE is 4.7, around here. When W is 2, it's 0. When W is 4 or 3, it's 4.7, around here. When W is 4, it's going to be something like this. Also, we can compute in the middle, or like this. They probably looks like a very nice curve. The learning is try to identify the weights which minimize the loss. In this case, it's this point. We want to identify this value automatically. We will talk about in the next lecture. Before we get there, we are going to get some hands-on experience using our model. The first, we have defined the model. Basically, x is as input. So we are going to make this as a function in Python forward, which gets x in the input returned automatically. It's very simple, x times w. The w in our case will take any random value, such as it can be started with 1.0. Then we compute the loss. We need x and y. Using the x, we can compute this prediction value. Using the y, we can find the difference and to square. And then we can just use these two functions and try to compute the loss with all w value. We have the sum of the loss. We initialize it and then we go with these data sets. First of all, in our case, w is well from 0 to 4. And each case is 0.1, and at every step we are going to point out w value. Then we have to sum the loss. Before we will initialize it, and then we go with this dataset and get x value and a y value. Then we get the prediction value, and using the prediction value, we can compute the loss. We sum the loss. And we are going to bring out these results. And MCE at each step, we can bring out divided by 3, which is the mean over the mean, the value. As you can see, when W is 0, the MSE is something like this. When W is changed, the MSE is going to change. Then if you want, you can draw a very nice plot graph like this. There are two variables which can basically say is W value, what is MSE value here. We can just say have these values we can plot, and we will see a very nice plot. This is our entire program. Hopefully, you will have no problem to understand, and you can implement this when use Python, and you can compute the loss based on our equation. So before we move to computer this automatically, I provided some exercise for you. First off, try to identify other interesting linear prediction problems, and if you can get some datasets, you can draw a cost graph for data. Also, let's see the axis again. Here is our code. The table of contents have 7 parts. The first, we given the datasets. There are 3 points, and then we initialize the weight with a random guess. We start with 1.0. Next, we define the forward function of our simplified linear model like this. Next, define the loss function of our model. Also, it's necessary to compute a gradient manually. Before training, we will test the prediction via function forward before training. We get this result. Finally, we implement the training process. At each step, we will get the W value and the loss value, and also the gradient of each point. Come back the next lecture. We are going to talk about how we can find out the best value, which keeps the lowest cost automatically using a method called gradient descent. Thank you for your attention.